Alright, so in this video we solved the partial differential equation, partial of u with respect to t equals to 9 plus 16 x squared, partial of u with respect to x plus 16u subject to the condition u of x 0 equals to 3 to the 7 arc tangent of 4x over 3. So to solve this partial differential equation, we're going to assume a solution of the form u of x t, that is a solution of the form uh, of a product between a function of x and a function of t. So we can do the separation of variables. And then we're going to take the partial derivatives of the solution of this form as required by the PDE. That is partial of u with respect x, which is the derivative of f, which is f prime, but g is constant here, so it remains g. And then the partial of u with respect t, that is f remains constant, so g gets differentiated. All right, well, so substituting this into the PDE, we get the partial of u with respect to t, which is f g prime, equals to 9 plus 16 x squared times f prime g plus 16u, but u in this case is the product between f and g. All right, well, again, the trick here to start the separation of variable is to divide both sides by the product AFG. Okay, so that is going to leave us with G prime over G equals to, cancel the G's, that's going to be 9 plus 16 x squared times F prime over F plus 16, because F and G, the product, cancels out. All right. Well, so to keep separating the variables, I'm going to move this 16 to the g side, that is g prime over g minus 16 equals 9 plus 16 x squared times f prime over f, which equals to, in this case, a separation constant that again we're going to call k. So at this point, we can already separate the two equations. All right, so let's solve the g equation. So g prime over g equals to minus 16 equals to k. So what I'm going to do, I'm going to add the 16 to both sides, and at the same time, I'm going to write g prime as dg dt, because again, keep in mind that g is a function of t, and that times 1 over g times dg dt equals to k plus 16. All right, separating the variables, all g's remain on the left-hand side, and all the t's on the right hand side, so that's k plus 16 times t. Integrating both sides, that's going to leave us with ln of g equals to k plus 16 t plus some constant of integration. Here, k plus 16 is just a constant. The integral of a constant is a constant times the variable we're integrating with respect to. All right, so we're going to exponentiate both sides on the base e, so we can cancel the ln on the left. That's going to leave us with g equals to e to the c, in this case is just another constant, that is e to the k plus 16 times t. So that's our solution for the g equation. All right, now for the solution to the f equation, well, let's do it on the side over here. 9 plus 16 x squared f prime over f equals to k. So because f, again, it's a function of x, well, f is the dependent variable, x is the independent variable, so I'm going to move the 9 plus 16 x squared to the right hand side by dividing it on both sides. At the same time, I'm going to write f prime as df dx, and this f in the denominator is 1 over f. That equals k over 9 plus 16 x squared. And let's keep separating the variables. Df over f equals to k over 9 plus 16x squared dx. All right? All right, so at this point, we're ready to integrate both sides of the equation. So, well, the integral on the left-hand side would yield an ln of f. And the integral on the right-hand side, so in this case, to evaluate that integral, well, that's not, a u substitution is not going to work. What works in this case is the arctangent rule, right? So the result of this integral with a equals to 3 and u equals to 4x, that is, let me write it down. So a equals to 3 and u equals to 4x. That is, a is the quantity whose square equals 9, and u will be the quantity whose square equals to 16x squared. That means the u equals to 4 dx. So in order to complete the dx over here, we would need a 4, multiply a 4, provided we multiply by the reciprocal of that outside of the integral. So that's going to leave us with 1/4 k times 1 over a, which is 1/3 arctan of u over a, which is 4x over 3. And in this case, plus another constant of integration. In this case, since we already used the letter c in the previous separated equation, we're going to use a different letter, d, in this case. All right, simplifying this, that's going to leave us with ln of f equals to 1 over 12k arctan, or simply much better, k over 12. It'll be better, k over 12 arctan 4x over 3 plus d, and exponentiating both sides on the base e, that is f, that's going to leave us with f on the left hand side, and that equals to e to the k over 12 arctan of 4x over 3. But actually, the e to the d, this is just going to be another constant d, right? And at this point, we already have the two functions whose product will comprise the general solution to the PDE. So we may go ahead and write that down. All right, so that is, coming back to the solution, u of xt equals to the product between f and g, which is f of x, g of t, that equals d e to the k over 12 arctan 4x over 3 times c e to the k plus 16 times t. And we can combine the two exponentials together, and also we could absorb these two constants of integration into a single one. Let's call that simply a. That's actually going to be our u of x t, and that's e to the k over 12 arctan of 4x over 3. And then, because we have the same base, what do we do with the exponents? Add them together. That's plus k plus 16 times t. And that is our general solution to the PDE. So now, we're going to use the condition to find the particular solution that is provided at the top. Let's go back. U of x0 equals 3 e to the 7 arctan of 4x over 3. Okay, so with the condition u of x0 equals to 3 e to the 7 arctan of 4x over 3, right? That means we're going to evaluate the general solution, replace any instance of t with a zero. That is going to be u of x0 equals to a e to the k over 12 arctan of 4x over 3 plus k plus 16 times 0, because t equals to 0. So this whole term is going to go all the way to 0. It's going to go to 0. So u of x0 gets replaced with 3 e to the 7 arctan of 4x over 3 equals to a e to the k over 12 arctan of 4x over 3. All right, and well, at this point, we can equate coefficients and coefficients of the exponential and coefficients of the arctan, because in this case, we have the same arctan function, the one that is, we have the same argument. So in this case, we can set k over 12, okay, so the coefficient of the exponential, so k over 12 equals to 7, and also the coefficient of e, rather, that means a equals to 3. So equating coefficients, that's going to give us a equals to 3 and k over 12 equals to 7. Well, k equals 7 times 12, which is 84, right? So that's 84. So this one, we may go ahead and go back to the general solution and substitute the value of k. Okay, that is a equals to 3 and k equals to 84. And that's going to give us the particular solution. So coming back, that is u of xt equals to 3 e to the 84 over 12 arctan of 4x over 3 plus 84 plus 16 times t. All right, so simplifying the 84 over 12, that gives us u of xt equals to 3 e to the 84 over 12. Is that equal to 7 arctan of 4x over 3 plus 84 plus 16. Is that equal to 100? 100t. Final answer.